Hello there! In this tutorial, we are going to be taking this Mario-style platformer and giving it a GUI. So we have a health indicator and a coin indicator, and well, whenever we collect a coin, we increase the coin amount, and whenever we touch an enemy, we are losing some health. So it's going to work like any other platformer. And all the levels and the overworld have been made in earlier tutorials. So check those ones out if you want to follow along. Unfortunately, to really understand this tutorial, I would really recommend to watch the earlier parts. It's going to help a lot. Now, besides the GUI, we are also going to work on the collisions between the coins and the player, and the enemies and the player. And specifically, the collision between the enemy and the player are a bit more finicky. So that's going to be a slightly larger section. And by the end of this, we have basically finished the entire game, bar a couple of bugs that I want to finish later and the sound. But I will add all of that in the next video. For now, let's talk about the GUI. And before we start working on the code, there's one really important thing I want to talk about. And that is how to store all the data for our player. In my case, there are 3 variables to make the GUI work. We have a coin amount, we have a current health, and we have a maximum health. And it is really important where we are going to store them. So technically, there are 3 different places where we could store them. We could store them in the game class, we could store them in the player class, or we could store them in the level class. And I really want you guys to think about which would be the best place to store them. There's an objectively correct answer here. And well, the correct answer here is the game class. And the reason for that is that only the game class is being kept around for the entirety of the game. Whereas both the overworld, the level, and the player are being constantly recreated. So for example, every time we create a new level, we are loading a level from scratch. So there's no way for us to store a coin or health information. The only class where we can store constant information in our game is the game class. So this is where everything has to be. And it's not really a limitation, it's just something to keep in mind and to think about how our code is going to work. Now, besides that, we also have to talk about a couple new folders. So let me show you. Here we have our graphics folder, and in there we have mostly folders we have already seen. So character, coins, decoration, enemy, overworld, and terrain are, well, what we already had in the last tutorial. The one new folder is called UI, and if I open this one, we can see a font, a coin, and a health bar. And we're going to use all of those in just a second. Now, besides that, we also have in the enemy folder a folder called explosion. And inside of that folder, we can see a couple of animation frames. So those we are also going to include. But, well, besides that, there's nothing else we really need. So let's jump into the code. And let's start working on all of this. All right, so here we are back in the main file, and I have a couple of files open that are the really important stuff we are going to need for now. I will go through what we are going to change one by one. But for now, we are going to be in our main file. And the first thing I want to do in here is that we can get rid of this from game data import level 0, because we don't need it anymore. That was a small thing that annoyed me in the past tutorial. But okay, now we can actually get started, and the first thing I want to do is to add a couple of attributes that we need. And those are, well, quite straightforward. So the first one, let's call it max health. And for me, this is just 100, but you could basically choose any number in here. Then besides that, I also want a variable that I called current health. And by default, this is also 100. And then finally, I want let's call it coins. And by default, this should be 0. And well, besides that, let me add a couple of comments. Let's call this overworld creation. And let's add a comment for this one. And let's call it game attributes. That is not how you spell that. And all right, so now we have our attributes. So with that, we have to figure out 2 different things. Number 1 is how can we update these numbers, and number 2 is how to actually display them. And let's start by displaying them. That's the, well, more visual part. So I'm going to create a whole new file that I'm going to save as ui.py. And in here, first off, we have to import Pygame. And after that, I want to create a class that I called UI. And in here, as always, we are going to need an init method that needs just self and surface and nothing else. And this surface here is just going to be the display surface. So essentially, in just a second, we are going to be passing this screen into the GUI so we can always access the display surface, which is going to help us enormously to draw stuff. And all right, in here, I guess the first variable, let's call it with a common setup. I want to set self.display_surface is going to be the surface we pass in here. So all we're doing in here is we're taking the surface and we're passing it in here. Now, besides that, for the GUI to work, we have to import 2 images and a font. So we have one image for the health bar background, one image for the coin, and then we want to create some text to indicate how many coins we have. So we have to import quite a few different things. And let me add different comments for this. Let's call the first one health, and then the other one is going to be coins. The first thing we need is self.health_bar, I called it. And all we really need in here is pygame.image.load, and the path to the file is going to be this one here. So we are going one folder up, then we go to graphics, then we go to UI, and inside of the UI folder, we have what's called healthbar.png. So if I open the actual folder in UI, we have healthbar, and this is a PNG file. Now, besides that, we also have to import the coin, which is going to happen in a very similar way. So I can just copy this line, move it down a tiny bit, and this one I have called coin. Now, with that covered, I want to create 2 methods. One method to show all of the health, so all of this, and another method to draw all of the coins. And that way we can update them separately, which is going to make our life a bit easier. And, well, all I need for that is, let's call it define show health. And in here, we need self as always. And besides that, I need 2 parameters in here. I need my current health, and I need my full health. And for now, let's add pass in here. We're going to cover that in just a second. And then besides that, I also want show, let's call it coins. And in here, we just need self, and then we need the amount. And in here as well, I just want to add pass for now. So this way we have our basic setup. Now the first thing that we are going to need is to actually blit those 2 images. And well, that's going to happen with self.displaySurface.blit. And for the health, we need self.healthBar. And for the position, well, you basically place it where you think it looks the best. In my case, I went with 20 and 10. And that would be broadly in the top left of the screen. And this we could actually already draw. And this could be a really good challenge for you. So what I want you guys to do is to initiate this UI class inside of the main file. So somewhere in all of this. And then only draw it when we are inside of a level. First of all, we have to create an instance of the UI. So I'm going to use a comment to create a new section. And in here, all I want is self.ui is equal to UI. And in here, we are going to need 1 parameter. And that is going to be that surface here, which in this case is just going to be this screen because we want our display surface. So that's all we need for this one. So this way we have initiated the UI. Now next up, we want to run this showHealth method once we are in a level. And this, fortunately, we can get very easy because we know down here when we are in a level. So what I want to do in here is self.ui.show_health. And in here, we have to pass in 2 arguments. So let me copy them. I want to get my current health and my full health. And for now, I am going to use random numbers, but later on, we are going to use those 2. But it's easier to illustrate if I just use random numbers. So let's say 50 for our current health and 100 for our max health. And with that, let's try all of this. And name UI is not found because I did not import it. So from UI, import UI. Now let's try this again. The game is still working. And now in the top left, we can see that we have the health indicator. So this is a really good sign. Next up, we have to display the coins. So let me go back to UI. And now we first have to show the coins and also show some text. And let's start with the coin. We already have the surface for that one. However, now we have a little bit of a problem. And let me explain why. So for the health bar, we could just place the top left in a position that's vaguely in the top left. But for the coin, this isn't going to be that easy. And that is because we have 2 elements we want to place. So we want to place the coin itself, and then we also want to place the text. And those 2 should have the same center position, so that one isn't above the other. And for that reason, we have to know where the center of each of them is going to be, which is something we did not need for the health indicator. So we have to do a little bit more here to display the coins properly. Now, fortunately, we can use rectangles to get the center of any kind of surface very easily. So we can just use rectangles here and we should be good to go. So I first want to get the rectangle of where the coin is going to be. And well, all we need for that is self.coin_rect. And in here, self.coin.get_rect. And I want to place the top left in the position of 50 and 61, separated by a comma. Now, these 2 positions are chosen entirely because they are looking good. There's no math behind this. I just played around where it looks the best. That's really all I did in here. And well, with that, we have a surface and a rectangle, so we can draw this. So in the showCoins method, I get self.displaySurface.blit, and in here self.coin and self.coinRectangle. And now that we have that, I can go back to my main file, and again, in the level just below show health, as a matter of fact, I can duplicate this one, and I called this one show coins. So show coins, and in here we need 1 argument, and that's the amount of coins. So let's say for now I just added 12 in here. And now let's run this. The game is still running, and now we get a second health bar. And I think the reason for that is, oh yeah, right, I did not update this one here. So this should be coin. And now let's try this again. There we go. This is looking significantly better. So with that, we have the health indicator and the coin. Now, next up, we have to get the actual text. And that's going to be a font. So I want to create self.font. And this could actually be a really good exercise to make sure that you understood the basics of Pygame. So create a new font, and for this font, you want to import the font we have in our folder for the UI. It's called arcadepy.ttf. We need pygame.font.font, and in here we need the font we want to use and the font size that we want to go with. Now the font size is just an integer, so in my case I went with 30. Now for the font, Pygame expects a file, and in my case the font is in the folder that has this path here that needs strings on both sides. So we're going a folder up, we go to graphics, we go to UI, and inside of UI we have the font called arcadepy, all in uppercase letters. And that is the font that is next to the coin and the health bar, so this one here. And to test if this is working, let's just run the game and go to level, and we can't see an error, which means we could at least import this font here. So alrighty, with that, we have a font. Now, next up, we have to use that font to draw some text. And this is going to happen all in the showCoins method. First of all, we have to create a basic text that contains the string of how many coins we are going to have. So I called this coin amount underscore surface. And well, all we need is self.font.render. And in here, we first of all need the information. Then if we want to anti-alias the font, and finally, we want the color. Now, all of those bits of information are fairly easy to get. The easiest one is if we want to anti-alias the text, which in our case, we do not because we have pixel font. Now, next up for the information, we want to have the amount in here. So literally just the information we pass into the method. That's all we need in here. However, there's one thing we do need, because by default, this is going to be an integer, because in our file, our coins are also going to be an integer. But Pygame for the render method expects a string. So this amount here has to be a string. So we want to turn this into a string with the string method. That's, well, fairly straightforward. Now, finally, we want a color. And in my case, I just have a color predefined. So this one here. And well, with that, we have a surface with some text. And next up, we have to get a rectangle of that, which I put into coin amount rectangle. And all we need in here is the coin amount surface dot get underscore rect. And now in here, we have to figure out where to place this rectangle to place the amount of coins we have. And let me explain what I am going to do. So right now we have the coin itself. So this thing here. And we know where this coin is going to be. It's just going to be this rectangle. So we have a rectangle broadly like this, and we know where the center of that is going to be. Now what I want to do for the coin text, essentially, I want to get the middle of the right side, then go a few pixels to the right, and then place the coin text broadly here. And what that means in terms of this getRect method is that I want to place this point here and essentially place it where the mid-right of the coin surface is going to be, and then move it a slight bit to the right. So I hope that makes sense. Let me actually leave all of this on screen and then type. First of all, we want to place the mid-left of the pink rectangle. And in here, we now need an X and a Y variable. Now the Y part is the easier bit, because all we want is self.coinRectangle.centerY. So this is literally just going to be the center of this rectangle. Now for the X argument, we essentially want to get the right side of this rectangle and then move a couple of pixels to the right. And well, all that means in practice is I want to get self.coinRectangle.right and then add a couple of pixels toward that. So in my case, +4. And now we can use that information to actually draw something on the screen. So self.displaySurface.split. And then here we have a coin amount surface and a coin amount rectangle. And let's try this now. And let's see how far we get. I open this, and there you can see in the top left, we have 12 coins right now. So this is working quite well. And now what we can do is actually use the coins we have and pass them into this argument here. So now when I run the game, we should be seeing 0 coins. And we do. So this part is working for now. So now we can display how many coins our player is going to have. That was the easy part. Next up, we have to work on the health indicator. And that is going to be slightly more difficult. And let me explain the major problem we have in here. Essentially, we have to convert between 2 different numbers. That in our game, we have the width of our health bar, and this we can measure in pixels. So in our graphic, we can have a health bar that is 152 pixels wide and 4 pixels high. So we have a specific pixel measurement. However, in our code logic for the actual player health, we have a number between 0 and 100. So we have to figure out how 100 health will get to 152 pixels. Or if we had 50% health, our health bar would be 76 pixels wide. So this is what we have to figure out. And this is going to involve a bit of math, nothing particularly difficult. But once we have that math, all we really have to do is to draw a rectangle that has a width of our health. That's really all we have to do. So that part is actually surprisingly easy. But well, with that, I think it's best to explain the math when we actually implement all of this. So let's go back into the code and let's have a look at this. So here I'm back in the main file, and I again want to work on my UI file. And before we talk about some math, I want to define a couple of attributes that are going to make our life easier. Now, first of all, I want to create a variable I call health underscore bar underscore top left. And this has a position of 54 and 39. So what does this do? Well, let me actually open the game, and that should make it easier to explain. So here we have our game. This is still working. And the coordinates I just specified are this point here, broadly. So we are going these two coordinates. And this way we know where our health bar actually has to start. So we have to place it somewhere on this graphic. And this is a measurement I literally just got from playing around with it. There's no specific math to get it. For the simple reason that it depends on where you placed this original health bar, so the background. But play around with this and, well, it should be quite easy to get. Okay, then besides that, I also have self.bar max width. And this in my case is 152. And then self.bar underscore height is going to be 4. So this is just going to be how wide our health bar can be and how high it can be. And well, the height is always going to be 4 pixels. So this one is not going to change. So with that, we have a couple of attributes. And now we have to start doing some math. So let me draw what we have to think about. So this here is going to be the maximum width our health bar can have. So this would be 152 pixels at the most. And we know that this is also going to be 100% of our health. So our health is going to be 100. Now the problem what we have to figure out is, let's say if our health is going to be 50, what is that going to be in pixels? So we have to find the ratio between these numbers. And we also want this to be flexible. So in our actual game, we might want to update our maximum health to something like 120. So let's say 120. And then we would still have to update the math to keep all of this correct. So if our maximum health was 120, then 60 and not 50 anymore would be 50% of the width of this bar. So all of this we have to keep in mind. It's a couple of different things. But let me go through step by step how I solved all of this. Now, first of all, I got what I called current health ratio. And this is literally going to be our current health divided by the full health. And that way we would get percentages in terms of how much health we have, not a specific number anymore. And that way it wouldn't matter what number our max health is going to be, because we would always get a percentage. So this is the first step to actually convert all of this. Now, next up, once we have that information, we can actually get the current bar width. And in here, well, all we need is our self.bar max width, and then multiplied by our current health ratio. So essentially all we're doing in here, we know that this number or this number up here is always going to be 152. And if our current health is 50% of the maximum, we only want to have, let's say, 50% of that. And that way, this number here, if we had 50%, the width would be 76. So with that formula, we will get a specific pixel width of our health. So that's super useful. And now that we have that, we can actually create a health bar rectangle. And this is just going to be pygame.rect. And in here, we need two tuples. The first tuple is for the position, and the second tuple is for the size. And well, most of the information here is very easy to get because the position, so the first argument here, we already have defined up here. So all we need is to pass this argument in there. So let me copy the entire thing and just pass it in here. Now, next up, we need the size. And the size is going to be X and Y. And Y we also have. It's just going to be the bar height. So I can pass this just in here. And now for the X argument, this is just going to be our current bar width. So I can pass this in here as well. And that is literally all we needed for our rectangle. So now we have a rectangle. And finally, we just have to draw it. So pygame.draw.rect. And in here, we need the surface, we need a color, and we need the rectangle. And let me go through them one by one. So the surface is just going to be self.displaySurface. And the rectangle is just going to be our health bar rectangle. Now for the color, I just have a predefined color. And that one looks like this. So this is just a reddish color. With that, we should be having all we need to display our health rectangle. So let's go back to the main file. Let's run this. And there we can see we have 50% of our health. And if I close this and change this number here from a 50 to, let's say, a 10. And go to a level again. And now we can see our health is down to 10%. So we know these two numbers work. So now I can get my max health and my current health and just pass them in here. So my max health and my current health. And now let's run this again. And there we go. Now by default, we have a full health indicator because, well, we have full health. But later on, we are going to reduce this. So this is also working. And with that, we have finished the first part, that we can actually display all of these attributes. Now, next up, we have to figure out how to update all of them. And in here, we have a minor problem that right now, all of our attributes are inside of the game class, but we actually want to update all of these inside of a level class. So we have to figure out how to go from the level and update something inside of the game class. And this is actually a problem we have already addressed in an earlier video, that when we wanted to switch between the overworld and the level, we also had to pass around arguments between the game class, the overworld, and the level. And this we achieve by passing methods inside of the overworld or the level. And via these methods, we could change the attributes. And this we are going to do just now as well. And let me start working on the coins. They are very easy to do, and it's very easy to illustrate how this system is going to work. And let's do this straight in code. So here we are back in the main file. And the first thing I want to do is to create a new method. And this method I have called change coins. And then here we need self and we need an amount. And the only line of code we need in here is self.coins plus equal the amount. And now this method I want to call somewhere in the level. So what I want to do is when I create this level to give it this self.changeCoins method. So literally all I'm going to do is I'm going to take this method here and pass it into this class. Very similar compared to what I've done with create overworld. So we have already passed another method in there. So with that, let's have a look at our level file. So this is a very long file, but the first thing we want to do is to add another parameter that I think I called change coins. And now inside of the init method, let's add another section here. Let's call it user interface. We have to actually turn this parameter into a proper attribute. So self.changeCoins is just going to be change coins. So now we can use this inside of this level. And this is going to be another method. So let me actually minimize all of the different methods inside of here. Otherwise, it's going to be impossible to read. All right, so now we can see all of the methods for the level class. And I just want to add another one. And let's call this one check_coin_collisions. And then here we need self and nothing else. And now all we really want to do in here is that if the player is colliding with any coin, we want to add a number towards our coin indicator. And this could be a really good exercise for you. So write the collision mechanic in here that once the player is colliding with a coin, we want to increase the amount of coins by 1. So I'm going to use sprite collisions. And since there is a very small chance that the player might touch 2 coins at the same time, I want to place all of this in a list. So I want to create a collided coins list. And to get that information, I want to get pygame.sprite.sprite collide. And in here, first of all, we want to get the sprite of the player. So self.player.sprite. Then besides that, we need to get all of the coins. And I call this one self.coinsprites. And finally, for the do kill, we want this to be true, so that once we are touching the coin disappears. And that's really important, because if it didn't, we would continuously add another coin, which would kind of break the game. But now once we have that, we can just check if collided coins, so if there's anything inside of this list. And if that is the case, for coin in collided coins, and then we want to call self.changeCoins. And in here for now, we just want to add 1. And that for now should be all we needed. So now all we have to do in the run method of our level, we have to actually call all of that. And I've put this right below checkDef and checkWin. So in here, it's just going to be self.checkCoinCollisions. And now back in our main file, let's try this. Let's see if this is working. So if I touch a coin now, there we go. We get 1, 2, 3, and so on. Now there's one problem with that all of our coins have the value of 1. So if I touch a gold coin, it acts just like a silver coin. So that's not ideal, but the basic mechanic is working. Cool. So now we have to figure out how to give each coin a different value. So back in my level and in this function, I don't want this to be a 1. Instead, I want to give each coin a specific value. And that is going to happen right inside of the coin class. So we created all of the coins in the tiles file. So in here, we have our coin class. And all I want to do is to give each coin a self.value. And the value is going to be determined by a parameter. So value here. So when we create the coin, we can give it a value. And then inside of our level, I don't want to change the coin amount by 1, instead by coin.value. So now we have to figure out when we create the coin, we want to give each coin a value. And this happened inside of create tile group. And in here, we have our coins. And all I really did in here is our gold coins have a value of 5 and our silver coins have a value of 1. And now this should be working. Let's try. And for the silver coins, I still get 1. And let me jump ahead a tiny bit. So there we can see a gold coin. If I touch this, we should have 10 coins at the end of it. And we do. And for the next one, this should get us to 15. And yeah, this is working pretty well. Cool. So with that, we get different values for different coins. So that part was quite easy. And with that, we can work on the slightly more complex part, because now we are talking about the player and the enemies. And in here, we have a couple of different problems. So let me talk through all of them. The first one is the actual collision mechanic between our player and our enemies, because there are two different kinds of collision that could happen. If we land on top of the enemy, we want to destroy the enemy and not reduce the player's health. However, if the player just touches the enemy from the left or from the right, in this case, we don't want to destroy the enemy and we do want to reduce the player's health. So we have to work with the collision mechanic here quite a bit. Now that brings us to the second problem, that once an enemy touches the player, we need to make the player invincible at least for a very short amount of time. And if we didn't do that, Pygame would register a collision every frame of our game, so once every 60 milliseconds. And this would effectively mean that if the enemy is touching the player once, Pygame would register 10 collisions and instantly kill our player. So we need some kind of timer in between there. But once we have an invincibility timer, we also have to signal this to the player. So we have to make the player flicker a tiny bit. And in my case, I use the alpha values for this. So the player is going to alternate between being visible and invisible as long as we are invincible, which is a very short period of time. And all right, that is quite a few different things. So let's go through these things one by one and let's start with the collisions. Oh, and I forget, also when our player is landing on top of the enemies and we're destroying the enemy, we also want to play a particle effect, so we can tell that the enemy is being destroyed. Although for this part, we already have our particle effects, that should be very easy to implement. So, all right, now let's start working on the collisions. So here I am back in my main file, and what I want to do is go to my level. And in here, I have minimized all of the methods, so it's a bit more readable. And the method I want to create in here is going to be called check enemy collisions. It needs self and nothing else. And now in here, we have to figure out the collisions between our player and our enemy. Pygame is somewhat limited in terms of how we can measure collisions. So this is the problem we have seen way earlier for our horizontal and vertical movement collisions. So we don't really know if something is colliding vertically or horizontally. So this is going to be kind of a problem for our collisions. Because we want to know, so if this is our enemy, if we are colliding either left or right, then we want to hurt the player. However, if the player is jumping on the enemy, we want to destroy the enemy. So we have to figure out how to get these different states. And I guess the easiest way to solve this is to not check for different directions, because this is kind of difficult to do. So instead, I did this slightly differently. Let me cross all of this and let's approach this problem differently. Here is going to be our enemy. And all I really calculated is that if the bottom of the player, so let's say this is our player, and I am checking the bottom of the player. And if the bottom of the player is in the top half of the enemy, so let's say if this part here is broadly in the top half of the enemy, and if my player is going down. If that is the case, I think it's quite safe to assume that my player is touching the enemy from the top. So if that is the case, then I want to destroy the enemy and not affect the player. However, if this is not the case and we still have a collision, then I am assuming that the player is touching the enemy either from the left or from the right. And this kind of logic is actually very easy to implement. It's just a couple of lines of code. Whereas the logic up here would be a ton of writing, and we would probably have to work with these two methods here to make all of this work. So I guess a really good practice here is to think about the problem you have, because there's a pretty good chance that a little bit of thinking about how you can solve a problem might avoid you doing a ton of math. Let's actually implement this. First of all, I have to know how many enemies I'm actually colliding with. And this is going to be a list, let's call it enemy collisions. And spelling this correctly would also help. And then here we just have sprite collisions again. So pygame.sprite.sprite collide. We again want to get our self.player.sprite. Then we want self.enemy sprites, I believe I called it. And then for do kill, this should be false. And that is because we need some information from the enemy. So I want to keep them around for now. Now, if there's any collision, so if enemy collisions, so we have something inside of this list. If that is the case, I want to go through all of my enemies. So for enemy in enemy collisions. And in here, I first of all want to get 2 bits of information. The first one is going to be the enemy center, and this is literally just going to be enemy.rect.centerY. And then I also want to get the enemy top, and this is literally just going to be enemy.rect.top. So this is going to tell me what the top half of the enemy is going to be. And I guess besides that, I also want to get the player_bottom. And this is self.player.rect.bottom. That's going to save me a good bit of writing in a second. And now all I really want to check, let me draw this actually. So here we have our enemy again. This is the center of the enemy. So this is going to be this bit of information here. And then the top is just this part here. And now all I really want to check is if the bottom of the player is inside this range here. So what that means is I need an if statement, so that if enemy top is smaller than the player bottom, and if that is smaller than the enemy center. And that is really all we need to get this range here. So a fairly simple if statement. But by itself, this would not be enough. And let me draw again why. Here again, we have our enemy. And right now, our player is, let's say, here. And the reason why the player is in this position is because the player just jumped from there. And in this case, well, we would want the player to be hurt because the player jumped, but he jumped from the side against the enemy. So in this case, the player just jumped too late. And as a consequence, we want the player to be hurt. But in the logic we have so far, so all of this, the player would be in the right range to defeat the enemy. So we need a second argument to make sure that the player is not going up, instead the player is going down. And well, all we need for that is the direction of the player, which is something we already have. Because all we need, if I find it, is this self.direction here, because this tells us where the player is going. So all I really want in here is end self.player.sprite.direction.y is greater or equal to 0. Either the player is going downwards or the player is standing on something that's on top of the enemy. And if that is the case, I know that the player is supposed to defeat the enemy. And if that is the case, well, I want to go for enemy.kill. So this would actually destroy the enemy. Oh, and this is something I didn't mention earlier, that the do-kill argument in here has to be false because there is a chance that we don't want to destroy the enemy. Because if the enemy is touching the player from the left or from the right, the enemy is supposed to survive. So this one really has to be false. Kind of important. But all right, so with that, let's actually try this logic. So back in my run method, I actually want to call this method here. All the way in the bottom, we need self.check enemy collisions. And now let's try this. Let's run it again. and we are getting an error. And this is happening inside of our level file. So let's have a look. So it's going to happen in our enemy collisions. And in here, the problem is that I forgot the sprite argument. And now let's try this again. Let's see what we get. And there you can see that if we're touching the enemy from the top, they disappear. And if I'm only from the side, they don't disappear. So this is working quite well. So this way, we already have one kind of collision. But there are a couple of problems with this right now. That right now, our player is just falling through the enemies. So instead, I want the player to jump up after we jump on top of an enemy. And also, I want to play a particle effect if the enemy is being destroyed. So let's work on them. Here I'm back in my main file. And first of all, I want to go to my level. And the first thing I want to do is if the player is hitting an enemy from the top, I want the player to have another jump. And to achieve that, really, all we need is inside of this if statement, I want to target my player, so self.player.sprite. Then I want to get the direction and the y direction and just set this to, let's say, -15. So this way, whenever we destroy an enemy, we are jumping up. And let's try this. And there we go. This feels quite nice. Let's try it again. There we go. So this is already feeling significantly nicer. And again, if we're not touching the enemy from the top, this is, well, not working. But if we do, this is working quite well. And okay, there we go. So this is already working. So now that we have that, I also want to play some particle effects to indicate that the enemy is being destroyed. And for that, we have to go in our particles file. And in here, we already have a couple of particles. We have the jump particles and the land particles. And all I want to do is to add another type of particle. So if type is equal to, let's call it explosion. And if that is the case, self.frames is going to be import folder, and the path towards that is this one. So in our graphics and enemy folder, we have another folder called explosion. And that is all we needed to change inside of our particle effect. Once we have that, I can go to my level and create an explosion underscore sprite. And really, all that is going to be is a particle effect. And in here, we need two arguments. And we haven't used particles in a while. Let me copy the parameters. So we need a position and a type. And I guess we haven't done an exercise in a while. So try to figure out the two arguments you need in here. They should be fairly straightforward. Now, the type is the easier part because, well, we are just checking for explosion. So I can just copy this string here and pass it in here. And with that, we have our type. Now for the position, this should also be fairly easy because essentially all I want is to spawn this particle effect in the center of the enemy. So all I want to do is enemy.rect.center. And that should be all we needed for the position. So next up, we have to add this explosion sprite to some kind of group. And I guess in here, you could put it into the dust particles. And that would be doable, but I would rather have a separate group just for the explosion sprites. So back in the init method, I am going to, let's say right below the dust, I also want explosion particles. And in here, I just want to have another sprite group that I called explosion underscore sprites. And this is just going to be pygame.sprite.group, and we're good to go. And now I can minimize all of this. And now I just want to get my explosion sprites and add my explosion sprite. And now finally, all we have to do in our, let's put it right below enemy, I need to get my self.explosionsprites.update, and this one needed self.world_shift, and then self.explosion_sprites.draw and self.display_surface. And that should be all we needed to create our sprites. So let's try this now. And let me jump on the player, and there we go. We can see a particle explosion. And let's check if this is happening if we don't jump on the enemy. And yeah, this looks pretty good. And let's try to jump on this one. And yeah, this is also working quite well. Cool. So with that, we have the top-down movement. So this was the first part we needed. So now for the second part, we have to figure out what happens if the enemy is touching the player from the left or from the right. So first of all, we have to figure out when that is the case. And that's actually really easy to get, because we know this is going to be happening only when the player is jumping on top of the enemy. So if there's any other collision, we know that the enemy touched the player from the left or from the right. So it's just an else statement. And in here, I want to run just one method that I called self.player.sprite.get_damage. I guess you could specify in here how much damage, but in my case, we only have one type of enemy, so we only have one amount of damage. But now we have to figure out a couple of different things. Let me go through it. Essentially, in our main file, we want to influence this variable here. However, we want to call it from inside of the player. So we have to figure out a way to influence this number from this player here. And well, essentially what we're going to do is the same thing we have done with these methods here, except now we're doing it for 2 levels. That we are going to create another method inside of our game class. We are going to pass this inside of our level, and from the level, we are going to pass this into the player. Now, I guess you could organize this a little bit better by creating the player sprite inside of the game class. And I guess this would be a slightly more elegant setup, but I don't want to make too many changes to the game, and this still isn't all that bad. So let's actually create this. In the code, I want to create another method. Let's call it change health. And here we need self and the amount. And all I really want to change is self.currentHealth plus equal amount. So those 2 methods here are essentially identical. Now, whenever I create a level, I want to pass this method in here. And I do want to spell it correctly. So besides change coins, I also want self.changeHealth. And now inside of the level, let me minimize all of the methods again. Besides the change coin parameter, I also want a change health parameter. And now this change health parameter, I am only going to use in the player setup. So this method is going to get a second parameter with a second argument that is just going to be change health. So now when we create this player setup in here, I also want to have a change health method. And now this change health method, we are going to pass into the player when he is being created. So I'm going to pass in change health in here. And now finally, in our player, we have to give this one another parameter that is going to be change health. And now once we have that, we can connect this to our level. Let me minimize this again. And in here, we have change enemy collisions, and we want to create a get damage method. So in our player, I guess in here we can also minimize everything, so it's a bit easier to read. All right, so in here, I want to create another method that I called get damage. It needs self and nothing else. And now for now, what we want to do is self.changeHealth. And in here, we can pass in an integer, because this method is essentially this method here, so we can pass in an amount. And in my case, I always want to reduce the health by 10. And I forgot one thing, that in the init method, we actually have to turn this argument into an attribute. So let's call it health management. And self.changeHealth is going to be change health. So we can actually use this change health method outside of the init method. All right, so now this technically should be working actually. Although you're going to see in a second that we have a massive problem in here. So the game is still working. This is still fine. And let me jump all the way down. And there, if you looked closely, you could see it quite easily, that our health disappeared immediately. And let me actually try this again. And let me jump straight here. And now look at the health. And it disappears immediately. And the reason is, let me go to the level, that this collision here triggers on every frame of our game. So about every 16 milliseconds. Now this is incredibly fast. And what it really means in practice is that if we are touching an enemy, Pygame is not going to see one collision, it's going to see a ton of different collisions. And this is going to happen way too fast for the player to react. So by the time we have a collision, the player is already dead. There's no time to react for the player to get away. So we have to extend this number here to something much larger. So the player has some time to escape once there is a collision with the enemy. And that means we need some kind of timer. Now, fortunately, all of this is going to happen inside of the player. So this isn't too difficult to manage. And I want to create a couple of additional attributes. The first one I called invincible. And this by default is going to be false. But once we have a collision, we are going to set this to true. Then besides that, I also want invincibility duration. So for how long we are going to be invincible. And I've set this to 400. And this is terrible spelling. Invincibility. I think that's spelled correctly, more or less. Okay, and then finally, we need to know when the timer is going to start. So we need to capture the time when the player collided with the enemy. And I call this self.hurt time. And by default, it's going to be 0. So now we have all the basic stuff we need for the timer. And the first thing I want to do is that we only want to change the health if self.invincible is not true. So if not self.invincible. And once we have changed our health, I want to set self.invincible to true. And since I then want to start a timer, I have to know when the timer is starting. So self.hurt time is going to be pygame.time.get_ticks. And I guess let's try this just for once in the game. And right now, what we would be expecting is that an enemy can hurt us once, but not twice. And this is working indeed. So now we are invincible, and we never switch off our invincibility. So the enemies can't hurt us anymore. But we can still hurt them just fine. So this is working just fine. So now we have to add the timer to turn this invincibility off again. And well, this is going to be another method. And let's call it invincibility_timer. And well, all we need if self.invincible is true, then we want to get our current _time, and it's going to be pygame.time.get_ticks. And then really all I want to check is if our current time minus our self.hurt time is greater or equal to our self.invincibility duration. On the timeline, this would look something like this. This one here is our time. And at some point, let's say here, we are running this getTicks. So this would be our hurt time. And after that, we check our time. So this is going to be this current time down here. And once this blue arrow is long enough, or at least longer than self.invincibility duration, then we know we have passed a certain amount of time. So this here is essentially going to be our timer. Once the timer has run out, we want to set self.invincible back to false. And now, don't forget, we actually have to call this. So self.invincibility timer. And now with that, let's try all of this. So now let me wait for this enemy here. And we get hurt once and twice because we didn't go away fast enough. But if I get hurt once and jump away, we only got hurt once. And I can still jump on the enemy and we don't get hurt. So this is working quite well. Let's try it again with this one. We didn't get hurt there. Now we got hurt. I could jump away. And if I jump on him again, our health didn't decrease. Okay, cool. This is working indeed. And I think maybe 400 was a bit low. Let's say 500. But again, here for this number, just play around and see what you get. This very much depends on your game. There's no objectively right answer. So with that, we're making some pretty good progress. But now we have a problem that the player doesn't really know if we are invincible or not. So we have to indicate this somehow. And essentially all I did is that if we are invincible, we are alternating between visible and invisible really fast. So it looks like we are flickering. So how can we get that effect? And well, that effect, let me actually draw it, is going to be achieved with a sine wave. And I'm not sure how much attention you paid in math class, but a sine wave is essentially a wave that goes up and down and up and down, and it always goes between 1 and -1. And the blue line is just going to be our time. And essentially all I'm going to do is that if on the sine wave we are somewhere here, so we are between 0 and 1, then the player is going to be visible. However, if we are between 0 and -1, then the player is going to be visible. So that way, we're going to switch between visible and invisible and continue doing this as long as we are invincible. And once we are vulnerable again, then this is going to stop. So, well, let's implement all of this. And the first thing we need is access to the sine wave. And this happens with a different module. So let's import it. And we need the math module. But I don't want to import all of the math module. So instead, what I want to do from math, import sin. And now we can use the sine value. I want to create another method. And let's do it right at the bottom. And let's call this one the wave value, because it's not exactly the sine value we're creating here. And I guess so far, all of this is quite theoretical. So let me actually demonstrate how this is going to look in the game. So I want just to create a value, and the value is going to be our sine value. And the sine value is going to be on the y-axis. So let me draw this again. Here we have our x-axis. And what the sin value is going to give us is the y value. So this is going to be the sine value. So we have to figure out what the x value is going to be. And in our case, the x value is just going to be our time. So essentially, all I want to pass in here is pygame.time.get_ticks. And now once we have that, let me just print it, the value, and let me also run self.waveValue. And let's actually see what we are getting. So if we run all of this, and let's run it for a second, there you can see it. So essentially, we start with 0.19, 0.4, then we go down, down, then up again, then down again, then up, and so on. So essentially what you can see here is a wave value that looks fairly inconsistent. And the reason here is because of our game loop. So depending on how fast this game loop is updating, this number here is going to be affected. Or well, these numbers. But if you were to graph all of them out, they would look something like this. So we are going up and down, except it's a bit more consistent. But the problem we have now is to turn this into a number we can use for our alpha value. So let me go back to the player. And the problem we have in here right now is that this value is going to be between 1 and -1. However, our transparency needs to be either 255, that's going to be the full transparency, or between 0, which is no transparency, so we are invisible. So we have to transform all of this into these two states. And well, let me draw all of this again to illustrate what I'm doing. Essentially, all I'm going to do in code is if we are above 0, I'm going to return 255. However, if we are below 0, I'm going to return 0. And well, that's quite easy. If the value is, let's say, greater or equal to 0, then I want to return 255. And if that is not the case, then I want to return 0. That way, this wave value here is going to return either 255 or 0. And this is going to switch depending on what time it is. So that is information we can then use. Let me minimize all of this. We can use it inside of our animate method, because in here we're actually drawing the player. And let me put this right after we finish drawing the surfaces. So if you remember, about 6 hours ago, here we are drawing the player. And we're just checking if he is facing right or left. And what I also want to check in here is if self.invincible, then I want to get an alpha value. And the alpha value we get from self.wave value. So then this value is going to be 0 or 255. And now all I want to do is self.image.set the alpha value is going to be this alpha value. If we are invincible, we are going to get this alternating value, and we are going to use that to set the transparency of the player. However, if we are not invincible anymore, so else self.image.set alpha is just going to be 255, so the full transparency. And well, let's try all of this. So now let me get hit by the enemy. And I can see I am flickering for just a tiny bit. So this is actually working quite well. And I can still jump on them. And this is working just fine. So, all right. That is actually working pretty well. I can jump on this one as well. I get hurt by this one. And cool. Now I can still collect all the coins. And we're good to go. So with that, we have covered all of the enemy collisions with the player. Now, with that, there's one more thing that we do need. That once our player is running out of health, we have to get to some kind of game over state. And I don't really want to create a whole nother game state. So instead, here's what I'm going to do. Once the player is running out of health, we are going to reset the max level to 0, the health to 100, and the coins to 0. So we are basically going to reset the entire game so the player has to start from scratch. Now, I guess for a real game, you would want the player to have the ability to regain some health or to get to a proper game over screen once the player has died. But in my case, the tutorial is already getting really long. So let's keep this short. And, well, let's create a basic game over mechanic. Here we're back in the main file, and all I really want to do is to create another method that I have called check game over. It needs self and nothing else. And all I'm really going to check is if self.current health is smaller or equal to 0. And if that is the case, self.current health is going to be 100. Self.coins is going to be 0. Self.max level is going to be 0. And then we are going to create a new instance of the overworld. Specifically, this one we create right at the beginning of the game. And as a matter of fact, we also want to set the status back to overworld. So I can just copy all of this and paste it in here. And now that we have that, all I have to do is to actually run this. And this is only really a factor in the actual level, so we don't have to worry about it in the overworld. So self.check game over, and then we should be good to go. And I guess while we are doing this, just for debugging purposes, let me set the get damage to -100, so we don't have to wait for too many collisions. So let me get hit by enemy, and there we go. Now we are back to level 0. So with that, we have a working game. And before finishing this video, there's one more very minor thing that I would like to do. And that is in UI. And in here, we are importing a couple of images. This one here and this one here. And what I did forget was to add convert alpha to both of them. And this isn't strictly necessary, but it is going to make our game run ever so slightly faster. So it's generally good practice, and I have a tendency to forget about this one. Let's try all of this again. And it is still working, and we can still jump around, and we can still jump on the enemies. We can get hit by them, and this is still working. So I guess now, just to finish the entire project, back in the player, I can set get damage down here back to 10. So that our game is going to run as it's supposed to be. And now if I try this, it is still working. I can get hit, and if I jump on an enemy, the enemy gets destroyed. So this is working very well. Cool. So with that, we have essentially finished all the major parts of this project. So if you have gotten so far, you have basically a really good understanding of Pygame at this point. Now, for the game itself, there are a couple of minor parts I still want to fix. Most importantly, the collision mechanics isn't perfect yet. So there are some instances where you jump against a palm tree and then you teleport around. And that is because our rectangle assignments for the player could be a little bit better. Besides that, we also have to add the sound, and we also have to add a tiny offset when we start the overworld. Because if you finish a level and keep on pressing a button, this button press is registered by the overworld when you start the overworld. So you might move in there even though you don't intend to. But all of this I'm going to add up in a final video that shouldn't be too long. But well, I hope you enjoyed the series so far, and I will see you in the next video.